Good afternoon to everyone. So today topic is volcanoes, right? So now, what is volcano? Anybody? So volcano is a natural phenomenon in which fire lava comes out from this underground, right? Underground on the which place earth surface, right? Underground on the surface. So this lava cools down and turn into clay or stone. So the world most dangerous volcano located on which place? Hawaii, right? Hawaii. So the mouth of volcano is called crater. So this is called vent. Okay. So it's called crater and this is called vent. So volcanoes of erupting nature are considered the most dangerous. So there are around 1500, right? 1500 active volcanoes in the world. So the volcanoes are usually found where tectonic plates are meet, right? So the lava of volcano is very, very hard. So the liquid inside the volcano, right? So now first we are going to deep about these volcanoes. First, want to know the what is magma and what is lava. You see here, right? So this is the picture. The the main difference you see here. What is magma? The molten rock that is underground. So it's typically hotter and denser than the surrounding solid rock. It's called magma. So the magma, this refers to molten rock that exists beneath the earth surface, right? Beneath the earth surface. It means it is a combination of molten or semi-molten rock and volatiles. Volatiles means such as water vapor and carbon dioxide and also solid materials. So that is called magma. And now what is lava? Lava is molten rock that has erupted onto the Earth's surface. The Earth's surface, as it flows, it cools and solidifies, forming new rocks. Right? So once magma reaches the Earth's surface, it begins to flow. It is termed as lava. Right? So the emergence happens through volcanic eruptions or fissures, right? So what is the difference between magma and lava? You see in this picture, the main differences between magma and lava is that magma is molten rock beneath the which one? Earth surface, right? And while lava is molten rock on the surface, right? So in addition to location, magma differs from lava in other respect too. These includes chemical composition and the temperatures, right? And composition, right? And composition and also behavior, right? So, that means location means magma occurs beneath the earth surface, right? So in the mantle and in chambers beneath the volcanoes, right? So the depth at which magma forms can vary. So for instance, magma can form a tectonic plate boundaries, right? Tectonic. Okay. Tectonic plate boundaries where plates are diverging or converging, right? And lava is on the earth's surface once magma reaches the surface, right? Okay. Through this volcanic vent. This is called vent. Okay, volcanic vent or fissure. So it becomes lava. And temperature, both magma and lava are hot. All of you know about this, right? So, but how hot they are varies. So magma is not necessarily hotter than lava. So the magma's temperature ranges, you see here, from 600, right? 600 to 1300 degrees Celsius. So it depending on its composition and depth. So the hotter the magma, the more fluid it is, right? And in this lava, temperature is upon reaching the surface, the lava starts to cool and solidifies, right? Cool and solidifies. And its temperature ranges between 700 degrees Celsius to 1200 degrees Celsius. So the exact temperature depends on the type of lava and how long it has been exposed to cooler atmospheric conditions, right? So this is the temperature of magma and lava and composition. So both magma and lava have diverse compositions depending largely on the source of the rock from which they form. So however, upon reaching the surface, some gases, right? Some gases and volatiles present in magma escape from the lava, right? So this makes the composition of lava slightly different from that of its magma, right? So it's like the difference between an unopened can of with the what is it called soda, right? Soda, it means which contains dissolved gases, right? So and an opened one means which is eventually loses its bubbles, right? So this is the difference between magma and lava. So now you see the what is the definition of volcano. A volcano is an opening in earth crust from which molten rock, right? So and hard gases and other materials erupts. So these eruptions can be explosive, um, releasing material high into the sky or quitter with gentle lava flows. So volcanoes are often found where tectonic plates meet, right? So particularly where they diverge or converge. A volcano is an opening, right? Opening in the earth crust. So through which lava, volcanic ash and gases escapes, right? So that is the volcano, right? So now you see some types of volcanoes. So there are on the basis of their activity and period of volcanoes are sometimes classified into three types, right? First one is extinct and extinct volcano, and second one is dormant volcano, and third one is active volcano, right? So these are the three types of volcanoes. Now, first one, uh, first we are going to active volcano, right? So, what is active volcano? Active volcanoes always pose the greatest danger. Why? Why? Because they continuously, you see in this picture, right? They continuously go on, right? So erupting and become a nuisance, right? So for the people or everyone, right? So a majority of the active volcanoes are located in the belt surrounding the, what is that? Pacific, right? Pacific, Pacific Ocean, right? Pacific Ocean. So that is known as the Ring of Fire, right? Ring of Fire, Ring, Ring of Fire. So they are spread over about 15 countries. So remember. So you see what is the definition? An active volcano is erupting often and could erupt any day. So this is the most dangerous type of volcano. So, right? So it is continuously go on erupting, right? So now second one is dormant volcano. So what is this dormant volcano? You see this one. Okay. So a dormant, like it is the sleeping and it has not erupted in a long time, but still might in the future. Right. So it means the dominant volcanoes are those which have not erupted. Right. Which are not erupted for a long time. So, but they can erupt again in future, right? Again in future. So, for example, um, empty Rainier, empty rainier. So in this cascades, it is in the USA, it has not erupted. So since long, long ago. So at present, it is quiet, but it has the potential to erupt again in which one? Future, right? So, and also another example is empty, right? Empty Pinatubo, P-I-N-A, Pinatubo. So, this is in the Philippines, right? So, this is another example of dormant volcano. So, which erupted in June, right? June 1991 after 6 centuries, right? So, and last one is extinct, this one, extinct volcano. So, it means an extinct volcano has not erupted. So, in the past, uh, 10,000, right? 10,000 years. So, this means that it is safe for all people. So, no harm for the this one, right? So extinct volcano. So extinct volcano like those of Devil Tower, right? Devil Tower in uh, Wyoming, Wyoming, Wyoming. So this is in USA. So those are such volcanoes which were active millions of years ago. So these are the three types of volcanoes, right? Now, you see here the types of volcanic eruptions. So the types of volcanic eruptions depend on which one? Various factors such as chemistry of magma and temperature, viscosity, volume, presence of groundwater and water and also gas contents, right? So these are the types of volcanic eruptions. And those are following the different types of volcanic eruptions. So that is first one is hydrothermal eruption. So this one is the eruptions include ash and not magma. So only ash. So remember. So they are driven by the heat caused by hydrothermal systems. So this is the hydrothermal eruption. And next one is phreatic eruption. Phreatic eruption is driven when the heat of magma interacts with the water. So these eruptions do not include magma and only ash. Only ash. Okay. And also next one is phreatomagmatic eruption. So this eruption takes place when there is an interaction between the newly formed magma and water, right? And next one is Strombolian and Hawaiian eruption. So the Hawaiian eruption has five fountains, while the Strombolian eruption has explosions due to lava fragments, right? So this is the five fountains and these are the lava fragments. And next one is volcanic eruption. So these eruptions last for a short period of time and it can reach up to a height of how much? 20 kilometers, right? And last one is subpleninian and Pheninian eruptions. So subpleninian eruptions reach up to how much? 20 kilometers in height, while Pleninian eruptions reach up to 20 to 35 kilometers, right? So these are the types of volcanic eruptions. And now we are going to volcanic products, right? Volcanic products. So there are three types of materials um, thrown out from a volcanoes. So the first one is gaseous products and liquid uh, products. So in the form of molten lava. And third one is solid rock fragments. So the substances in gaseous, liquids and solid forms, volcanic products come out from volcano through eruption, right? So now so the eruption products and hazards. So the many hazards that can, you see here, this. So now you see first one is gaseous products, right? So these are the important gases of volcanoes. It contains water vapor at 80 to 90%, right? So the volcanic gases and other volatiles. Volatiles means hydrogen sulfide, water vapor, sulfides and carbon dioxide, nitrogen and hydrochloric acids. So these are the gases products. And these are liquid products. Another product is liquid products, right? So the liquid product mainly consists of lava, right? So lava, this is the red in color. So in which gases and many types of minerals are mixed in these products, right? So on the basis of the amount of silica, it can be add silic lava and semi-silic basic lava. So heavily silicated lava in which the amount of silica is more than how much? 75%. More than 75%. So due to being more viscous and it flows slowly and solidifies quickly. So heavily the silicified lava is thin and melts quickly and flows fair. So it contains about 40% of silica, right? And next one is Hoho Hoho lava, right? Hoho Hoho lava. So, which is basaltic lava. So, which has a low viscosity. It cools moderately, slow and rope-like appearance, right? And next one. And A lava, so this is also basaltic lava. It has higher viscosity and it is solidifies wide, flowing and also angular pieces, right? And third one is pillow lava. The lava acts under water, right? Under water, cools and contains spherical masses like see in this picture, and these cools under oceanic flow, right? So the spherical masses are like this and this color under the water, right? So this is called as spherical masses, right? So So the eruption products in hazards, that is many hazards that can be deadly to human life, right? And damaging to the landscape because of volcanic eruptions, right? So those are the result of three main volcanic products, that is lava flows, gases, and pyroclastics, right? So right. So lava flows, it means lava flows are the molten rock, right? Molten rock. It moves, it moving over the ground, right? Ground and then solidifying. So how quickly and how far these flows will travel? It depends on the viscosity of the magma. So as discussed about this explosivity. So and basaltic magma. So it will be the least viscous and andesitic magma more viscous and also rhyolitic magma is also. So that is the most viscous. So as the least viscous magma, that is basaltic lava flows move at the um, highest speeds, right? It traveling as fast as how much? 10 kilometers per hour, miles per hour. So although it can move over 30 kilometers per hour, under the right conditions, and it can flow for long distances up to several hundred kilometers. So much like water flowing over a landscape. So this flow will be controlled by topography, and it will accumulate and flow further in low lying landscapes like which one, river, right? River valleys. So as the basaltic lava cools, it forms various structures and textures is there, right? So as the lava cools down, it forms a skin of cooler and a stiffer lava that overlays the hotter runnier lava. So if flows is relatively slow under the skin, the cooled surface is um, pushed, right? So pushed into a distinctive ropey texture. So that is called Pohiohia lava, right? So the top right picture is the close of the view after a cut has been made to show the internal structure of the this wrinkled lava flow, right? So you see here, can notice this one. Many holes, right? Many holes are vesicles within the lava. It formed when the lava solidified around this gas bubbles, right? Gas bubbles. So if the underlying flow is more rapid, the cooled surface is instead broken into sharp and blocky chunks in a texture. So that is called you see here this one, A on there, A. So, right? So, the bottom left image, this one, it shows a close-up view of the advancing front of and shows an older cooled uh, lava flow. It viewed from the side, right? This one. So, when lava flows into water, a structure called which one? Pillow lavas, right? Pillow lavas. So pillow will form, right? So these can occur if lava erupts under water. Okay, under water. Or if lava flows across the land and into the water, such as is seen in some coastal areas, on example of Hawaii, right? Hawaii. So, as lava enters the water, the outside of the lava cools quickly, right? So, it making a tube, right? So, like this one. So, now you see, and also these pictures. So, thick lava flows cools on land. They contact and crack, right? Crack into distinct hexagonal, right? Hexagonal columns called columnar joints, right? Columnar giants. So this feature is commonly seen in which one basaltic rocks, right? So, but it can be found in other compositions as well. So the giants you see in this picture, as these shapes allow for efficient packing with the minimal wasted space or material, right? And hazards from lava flows, those are given the speeds, right? The speeds at which lava flows travel and death caused directly by a lava flow, right? Lava flow is very rare as most of the people are able to move out of the way of an oncoming flow, right? So even though there is low risk to human life from lava flows. Everything in the path of an advancing lava flow, it will be knocked over and surrounded, buried, or ignited. So by the extremely hot temperature of lava. So this lava flows therefore affect populations by burning homes, burying farm fields, and destroying infrastructures, etc., etc. Right? So the extent of indirect effects or lava flows on populations can be seen by looking at what happened this following in this is the May 21st figure, right? May 20 sorry 2021 figure erupted on empty which place this one Congo Nirangongo in the Democratic Republic of the Congo, this place, right? So this was an effusive eruption of basaltic lava that resulted in more than 30 fatalities including, right? So the two people who did not have the assistance, they need to leave their homes to escape the lava, right? And that in that instant, approximately 230,000 people were displaced without adequate supplies, including food or clean drinking water, and resulting in outbreak of cholera flows, right? And 1,400 children were separated from their parents. So because the reason of this May 2021 eruption of FD Nirangongo, Democratic Republic of Congo, lava, right? So eruption, lava flows, this one. And the volcanic gases. And so volcanic gases means magma contains gas, right? And most of the gas emitted by volcanoes is water, right? Water, but carbon dioxide, CO2, and carbon monoxide, CO, and sulfur dioxide, SO2, and also hydrogen sulfide in order of decreasing abundance are also emitted, right? So at high pressure, these gases are dissolved in the magma. But if the pressure decreases, it means such as when magma moves closer to the surface or when a volcano is erupting. So the gas comes out. You see some in this picture. Gas comes out of solution and forming bubbles, and similar to what happens when opening a bottle of pop, right? So pop is bottle under pressure, forcing carbon dioxide gas to dissolve into the fluid, right? So as long as the bottle is closed and the pressure remains high, so there will be few to no bubbles in the pop, but as the bottle is open, the pressure is automatically is released along the dissolved gas to rush out. So the puff will begin to fill as carbon dioxide comes out of solution and forms bubbles. So the small vents on the ground through which volcanic gases escapes are called fumaroles. Fumaroles. You see here, this one, right? Fumaroles. So this picture is taken in Dalur Valley, that is island, which is a highly active geothermal area. It's full of fumaroles, right? Fumaroles. You see here, this one here and here, right? So full of fumaroles powered by the underground magma in this region. So the clouds rising from the ground are mainly steam, right? Steam means water. So but also contain other volcanic gases and give the area the distinct smell of hydrogen sulfide. So hydrogen sulfide means so smell is hydrogen sulfide smell is that is rotten eggs, right? Rotten eggs. Okay. So these are the fumaroles figure. And hazards from volcano gases. So that threats to humans from volcanic gases are varied and it can cause short-term immediate illness or death or create longer-term changes to the climate, thereby affecting crops and ecosystems and also human health, right? So the section of pyroclastic materials will uh, discuss in this slide, right? Right. So the pyroclastic materials. So as gas bubbles escapes, they can violently propel lava and other materials from a volcano, right? So the particles ejected from volcanoes are called pyroclasts, right? Pyroclasts. So, which leads to the general collective names of pyroclastic materials or pyroclastic debris. So, these pyroclasts can be ejected as high as troposphere. Troposphere means up to 20 kilometers, right? Or even stratosphere. So, that is up to 50 kilometers altitude where it can be transported great distance by the wind. So once this material settles on the ground, it is called tephra, right? Teph. Tephra. Tephra. So it means although in practice in the terms tephra and pyroclastic materials or debris often get used interchangeably despite the subtle differences in definitions, right? So that is called tephra. So while if effusive and explosive eruptions, it can both produce pyroclastic materials. So the volume and type of pyroclastic material produced the attitude to which pyroclast are ejected and the area that is affected by pyroclastic materials. So those are all typically much greater with explosive eruptions, right? So now pyroclasts are classified according to their size, right? So in that first one is largest and medium and smallest. So this three types is there, right? So according to their size, okay? So in that first one, largest is those are lava blocks and bombs. This one, first one. Okay. So that is greater than how much? Greater than 64 mm. Greater than 64 mm. So blocks are made when solid parts of the volcano shatter and are thrown during an explosive eruption. So these bombs are large blobs of lava that are ejected and cooled as they travel through the air and causing many to take on streamline shapes also, right? So, and those are the lava blocks and bombs, right? And that is greater than 64 mm, okay? And medium size, so that is second one. Medium size, so those are called lapilli, right? Lapilli. So that is 2 mm and 64, 2 mm to 64 mm, right? So those are droplets of lava that cools in the air. So these can take on glassy teardrop shapes, right? So it get pulled out into the thin glassy strands, right? Or from small gravel-like pieces, okay? So that is lapillis. And last one is third one, ash, right? So ash means less than 2 mm. Less than 2 mm pyroclasts are called ash. So it can range from microscopic to visible at its largest. So these are small mineral grains and volcanic gases, right? So now classification of volcanoes, right? Classification of volcanoes. So volcanoes are grouped into four types, right? So first one is um, cinder cones and composite volcanoes and shield volcanoes and also lava volcanoes. So these are the four types of volcanoes here. So classification. So what is the cinder, right? Cinder cones. Cinder cones means cinder cones are this circular or oval cones, right? So you see this one, right? It made up of small fragments of lava from a single vent, right? Single vent that have been blown up. So the cinder cones results from eruptions of mostly small pieces of scoria and pyroclastics. So that build up around the vent, right? This vent. This is called vent. Okay. So this is cinder cone crater. It's called crater. So this is called vent. Okay. And this is called tephra layers. Okay. And most cinder cones erupt only once. Remember. So the cinder cones may form as flank vents on larger volcanoes or occur on their own. And second one is composite volcano. So composite volcanoes are steep-sided, right? Steep-sided volcanoes. It composed of many layers of volcanic rocks. Usually, it made from high viscosity lava, right? High viscosity lava. And ash and also some of the rock debris. So these types of volcanoes are tall conical mountains composed of lava flows and other ejecta in alternate layers, the strata that gives rise to the name. So this is called composite volcano. So now you see this one alternating layers of lava and pyroclastic materials. So this one and Okay, so this is vent. Before slides, you can observe. And this is the country rocks and magma chamber is there. And also flowing lava, you can observe. And also crater. This is crater and this is called vent, right? And you see this one, steam and ash. Okay? And the next one is, okay, shield volcano. So, what is the shield volcanoes or what are the shield volcanoes? So, shield volcanoes are volcanoes shaped like a bowl shape, right? Are shield in the middle with long, gentle slope made by basaltic lava flows. So, now you can observe in this figure. So, these are formed by the eruption of low viscosity, right? Low viscosity lava that can flow a great distance from a vent, right? This vent. Okay, this is the magma chamber and this is the earth crust. Red color is earth crust. So it's called vent. Okay. So now you see here, so those are gently sloping slides here and layers of the solidified lava. Okay. So they generally do not explode catastrophically. So since this low viscosity magma is typically low in silica and shield volcanoes are more common in oceanic than continental settings. So example is the Hawaiian volcanic chain, right? So the Hawaiian volcanic chain is a series of these shield cones. They are common in Iceland as well, right? And last one is dome, right? Dome lava. So you see here, these lava domes are formed when erupting lava, right? Erupting lava is too thin, right? Is too thin or thick, sorry, too thick to flow and makes a steep-sided mountain as the lava piles up near the volcanic vent. This called vent, right? So they are built by slow eruptions of highly viscous lava, right? So they are sometimes formed within the crater of previous volcanic eruptions, like a composite volcano, right? So they can produce violent and explosive eruptions, but their lava generally does not flow far from the originating vent. Okay? And one second. Next one is distribution, right? Distribution or occurrence. Right, you see this picture. Okay. So the volcanic activity is widespread over the earth, right? But tends to be concentrated in specific locations, right? So the volcanoes are most likely to occur along the margins of tectonic plates. So especially in subduction zones, that means where oceanic plates dive under continental plates, right? As the oceanic plate subducts beneath the surface, intense heat and pressure melts the rock, right? The molten rock material, magma, can then ooze its way towards the surface where it accumulates at the surface to create a volcano, right? So volcanic activity can be found along this mid-oceanic ridge system, right? Mid-oceanic, sorry, ocean ridge system as well, right? So here the oceanic plates are diverging and magma spreads across the ocean floor, ultimately being exposed at the surface, right? And crustal spreading along the ridge is partly responsible for this volcanic activity of Iceland. So it is also thought that a hot spot, right? So it lies beneath the Iceland that contributes to right? Volcanism. So now you see here, the volcanic activity in this picture, the red lines, right? The red lines are volcanic activity, right? And lithospheric plate boundaries is there, right? So now what are the hot spots? Hot spots are places where chambers, right? Where chambers of magma, it has accumulated at depth beneath the surface. And the volcanic islands of Hawaii, those are the notable examples of this hotspot, right? The Hawaii Islands ride it top the Pacific plate as it moves in a northwesterly direction over the hot spot that creates the volcanoes. So therefore, the oldest volcanic island is found at the northwest end of the chain and the youngest to the southeast. So the volcanic activity ceases as the older islands move off the hot spot, right? And so, what are the causes of volcano? Anybody? So, causes of volcano, that is volcanoes, first one is distribution, right? Distribution of volcanoes are found along convergent and divergent and also some other continental plates, right? So, the convergent boundary volcanism is subduction of one plate under the another in cases of convergent plate boundaries. So that is result in the melting of rocks due to which one? High temperature and high pressure. So that rise along the fissures of rocks, right? And divergent boundary volcanisms, in the case of divergent boundaries, that is thinning of the upper crust. So that leads to a reduction in the overlying pressure of rocks. It causing a decrease in rock melting points and formation of magma, which rises and erupts as lava from fissure volcanoes, right? And some continental volcanoes are located away from plate boundaries due to the stressing of plates and the creation of faults. That is intraplate volcanism, right? And some example, ring of fire runs up along I already told about this western coast of South and North America, right? It runs down the eastern coast of Asia past New Zealand and into the northern coast of Antarctica, right? So, the features of volcanoes, a volcano is an opening the surface of the earth. So, from where, from which magma and associated gases and ash erupt, right? So that is also the form of structure, sometimes conical. So that is produced by the ejected material, right? So the volcanic activity, it may create vast plateaus where flood basalts emerge from cracks and covering the surface with the massive flows of lava and subsequently dissected by streams, right? So the common to all volcanoes is this magma chamber, right? This magma chamber. So the magma chamber is a huge, right? Huge subterranean cauldron of molten rock. So that is less dense than the surrounding rock and rises buoyantly. And sometimes under great pressure to the surface, the main so which the main conductor through which magma moves towards the surface is the central vent, right? The central vent. And also this is called crater. Okay. So a crater sits at the top of a volcano and it is the location where much of lava and gas, rock fragments and ash. So those are ejected from there. And lateral vents are found in the on the sides of some volcanoes where lava is erupted, right? Sorry, extruded. And extremely, this large crater is sometimes found at the summit of volcanoes, right? And these massive craters called calderas. So those are created when pressure builds inside the volcano until the top is literally blown off and magma drains back into this central vent, right? The central vent and the top of the cone collapse. So the crater lake formed in the caldera of Mount Mazama, right? So the volcanic eruptions, especially explosive eruptions, right? And eject fragments of volcanic rocks and lava collectively called, what is that? Tephra, right? I already told about this tephra, T-P-H-R-A, tephra, right? And the ground hugging pyroclastic flows of fast moving gas and fragments of rock having temperatures How much? 500 degrees Celsius can rush down the flanks of volcano at speeds searching 100 kilometers per hour and carbonizing all in their path. So the volcanic eruptions are um, accompanied by the this release of these some of the gases, right? And sometimes lethal gases. And steam makes up this majority of gas that is released by a volcano, followed by carbon dioxide. And which one? Um, right? And sulfur dioxide and also hydrogen chloride, right? So when lava spills into the ocean, the intense heating of salt water produces a noxious steam cloud of hydrochloric acid, right? So the sulfur dioxide combines with water in the atmosphere to produce which one? Acid rain, right? Acid rain. So it naturally produced acid deposition around the top of Mauna Loa has devastated the local vegetation, right? Local vegetation. So this is the volcanoes. So now, what are the most active volcanoes? The most active volcano in the world is found um, in the Kilauea volcano. This is the Hawaii, in Hawaii. So other most active volcanoes are Etna in Italy and Piton della Fornace on a La Reunion Island, right? So what are the volcanic rocks? Volcanic rocks are the igneous rocks, right? So that are found in volcanic regions, right? Volcanic regions. So they are fine grained and glassy textures rocks. So these rocks are also vesicular in texture, which is in the form of voids that are created by the volatiles. So that try to escape from the molten lava. So these volcanic rocks are named based on their which one chemical composition, right? So that is very important. The most common volcanic rock is basalt, right? Basalt. Okay. So these are the volcanoes. So now today class is over. Mhm.